All right, here's another medication order problem. You get a medication order. Patient is supposed to get Clotrix, which is a brand name for potassium chloride. And this is the dose. They're supposed to get 0.35 milliequivalents per pound of body weight. That's what that means. Now, what the heck is milliequivalents? You don't know, and you don't need to know. All you need to know that it is a unit for an amount of this drug. So it's telling you in this dose here how much drug, there's the drug units, per pound of body weight for the patient. And you're supposed to put it in 6 ounces of OJ as orange juice at 8 a.m. All right, so that's your order. So now you go and you find out you've got some Clotrix, but the concentration of it is 8 milliequivalents per milliliter. All right, so that's telling you how much drug you've got in a milliliter, basically. So now your problem is, how do you carry out the order? How many milliliters of Clotrix solution are you going to need to add for a 20.5 kilogram patient? You're going to put it in their orange juice, 6 ounces of orange juice. Okay, this seems like kind of overwhelming because there's just so much information here. But this is where that general strategy is going to come into handy. What you need to do is focus on one thing at a time so you don't get lost. The very first thing that you do in the general strategy for unit conversion is find the target. What are you trying to figure out? Now you look for words like how many milliliters. So you're trying to find milliliters of Clotrix. We've already got our roadmap started. All right, now I need to figure out what am I turning into milliliters. Look at the way the problem is phrased. How many milliliters of Clotrix do you need to add to a 20.5 kilogram patient's OJ? Now, we understand a little bit about what's going on here. This tells you how much drug per pound of patient. So the patient's weight is going to determine the dose here. So I think what I'm going to do is start with the patient's weight and use that to figure out how many milliliters of Clotrix I need. So there's my starting point. Now, the next thing I've got to do is I have to link the patient's weight with an amount of Clotrix. So I'm going to look through the problem for something that links the patient's weight to the amount of Clotrix. And here, it's the dosage up here. This is the amount of Clotrix, whatever those units are, milliequivalents, per pound of patient. So if I put pounds of patient here, and I put milliequivalents in here, I know that there's 0.35 milliequivalents of Clotrix for every 1 pound of patient. So that's my link there. This is the critical link. How did I find it? How did I reach in and find the one link that is going to cut the problem into easier pieces? Well, I'm going to look at what I'm starting with and what I'm ending with. I'm starting with a patient's mass, and I'm ending with an amount of Clotrix, a volume of Clotrix if you want to be specific, but it is an amount of Clotrix. So my critical link, the one that's in the center, has to link the patient's mass with the amount of drug that I'm trying to give here. And this dose up here is the bit of information that does that. Now that I've found that critical link, the problem is a lot easier. Now, you may have learned to do these kind of unit conversion problems in high school by starting at the beginning and grinding through, canceling all the units out till you get to the end. But you see that that's not going to work out so well for you here. What you need to do is develop a strategy by finding the critical link first. drop the critical link in the middle of your roadmap. And now all I got to do is turn kilograms into pounds, which isn't too bad, and milliequivalents into milliliters, which I can see I can do right here because I have the concentration of the Clotrix. There are 8 milliequivalents of this drug per milliliter of solution. Let's write that into our roadmap. 8 milliequivalents of the drug in 1 milliliter. So that's my link. Now I need a conversion between kilograms and pounds. So how do I find this? First of all, this is a metric unit, and this is an English unit. This is a metric mass unit, and this is an English mass unit. So what I need is an English to metric mass conversion. So I'll go out and look one up, and maybe I find this one. 453.6 grams is 1 pound. Now notice that isn't given in the problem, but you're going to need it. This is how real life is. Not all the information you need is given. Some of it you're going to have to realize that you need to go look up. And how do you know what you don't know? If you're doing this roadmap, in order to make the link between kilograms and pounds, I am going to need to have an English to metric mass conversion. And I'm going to have to go look it up if they don't give it to me. So here I have a gram to pound conversion. But I got kilograms there. I'm going to drop the grams in there. This is the gram to pound conversion. And now I need a kilogram to gram conversion. Now you should know this one. 1 kilogram is 10 to the 3 grams. That's from your prefix table that I asked you to memorize. So now we've got a roadmap. It goes from the patient's weight in kilograms to grams, and then to pounds. And then for each pound of the patient's body weight, it turns that into an amount of Clotrix, of drug. And then we're turning the amount of drug that we want to deliver into milliliters. So now we can turn this into a calculation. Now I'm going to write down my starting point again. And there's my conversion factor. I'm going to take my first link from the roadmap and turn it into a fraction. What do you think I should put on the bottom? Should I put kilograms on the bottom or grams? If you said kilograms, you're right, because I want to get rid of kilograms. And if it's on the top here and the bottom here, it's going to cancel. Okay, so there. That will cancel out the kilograms. And now I'm in grams. So let's go to the next step, which is go into pounds. I'm using this link here. What should go on the bottom? Grams, because I'm trying to get rid of grams. And then the pounds has to go on the top. And sitting next to the grams is 453.6, and on top is 1 pound. Okay, that gets rid of the grams. Cross them out as you go along. Now you're at pounds. Now I want to go from pounds to milliequivalents. And I don't know what the heck a milliequivalent is, but 1 pound is equivalent to 0.35 according to the problem. And I want pounds on the bottom so that the pounds will cancel. See, it becomes very mechanical once you have a roadmap to follow. Getting the roadmap is really the hard part. So there's 0.35 milliequivalents in 1 pound. One more step. I crossed out pounds. I've got milliequivalents, and now if I can get rid of that, I'll have milliliters. All I got to do is put the milliequivalents on the bottom. And I'm using this link here. There's 8 milliequivalents, so there's an 8 sitting next to it. And on the other side, there's 1 milliliter. And that's it. That should give me how many milliliters I need to put in this patient's orange juice to give them the proper dosage. Let's figure it out and see if the answer comes out to be something reasonable. Okay, I got 20.5 kilograms times 1E3 is how I'm going to key that in. 1E3. So that's the 10 to the 3. Divided by 453.6 times 0.35. I'm dividing by anything that's on the bottom and multiplying by anything that's on the top. So divided by 8. Divided by 8 gives me 1.977 milliliters. Now everything in here canceled out except the milliliters. Now, am I going to measure it out that fine? I think not. How many significant figures do we have here? Maybe one. Probably when it says on the bottle 8 milliequivalents per milliliter, they're not reporting the significant figures as exactly as they actually have them. But I would say one significant figure is probably going to be good if I didn't know any better. So really it's 2 milliliters. So I'm going to add 2 milliliters of this drug to 6 ounces of orange juice for this particular patient. Now you try it.